Hi friends, welcome to follow up. Let's have a look at problem 72, edit distance. In this video, we are going to explain a solution based on dynamic programming, continuing our practice for dynamic programming from the two previous videos. So this problem, edit distance, actually is a very classical problem now. And also, if you are majoring in natural language processing, right? So this edit distance is actually some very basic practice. So here, let's first look at the statement, and then we explain the code, and finally we make some comments. So here we are given two strings, word 1 and word 2. We want to find the minimum number of operations required to convert word 1 to word 2, right? So we have the following three operations permitted on the word. Either we insert a character or we delete a character. So these two are relative, right? If you insert one character to make it equal to another one, it corresponds to delete one character from the other string, right? So you can see they are actually towards different different parties, right? So also we can replace a character, right? So here we have two examples. In the first example, you have a house and you have rows. So basically, you can use three operations to make them the same. So similarly, in example 2, there are 5 operations needed. So you can, for example, pick one. So here we should comment that the minimum number of operations is unique. However, the way to make the two words or two strings equal are not unique. And also, let's look at the constraints. First, the length of the two lists, or not two lists, two strings, are bounded above by 500. Secondly, word 1 and word 2 consist of lowercase English letters. So with that said, we are ready to do the analysis and explain the DP interpretation. So here I want to use dynamic programming. So there are many ways to do this problem. So here I'm going to use a DP table. So here let's use dpij, right? So the interpretation will be the following. So I want to have the minimal number of operations to make so as let's say word 1, so up to index I, and w2 up to index j are the same. So here, in other words, we if we think of index, so here we stop at index I minus 1. Here we stop at index j minus 1. Or you can see as we use DP table of size, say m plus 1 times m plus 1. So here I'm using the convention that m and n are the length of word 1 and word 2 respectively. So if we use such a table size, so we actually can interpret this I and j as length, right? So once when the length equals m and n respectively, in other words dpmn, that's the required result, or what we want to return, right? So with this explanation, so now I guess we can directly write the code, and in between we can explain the DP update rule. So here we have word 1 and length word 2. So here I changed the two words to w1 and w2 for convenience of writing. So now let's initialize a DP table, right? So when we initialize the DP table for the inner one, so we can do this, n plus 1. So this n plus 1 is the number of columns in this 2D table, right? And then we cannot, like one, multiply by m plus 1. Here the reason is that for a list, it's mutable, right? We need to avoid this situation. So here we are going to do for in range m plus 1, right? So now, once we have done this initialization, we want to further initialize something, because that's actually corresponding to deletion. For example, dp00, both the two words have 0 length, so they are equal, so we have 0. And then for the first row and the first column, we can decide. So let's first determine the first row. For j in range from 1 to m plus 1. So in this case, word 1 corresponds to empty, and word 2 corresponds to some characters. So in this case, we can only insert corresponding character in the first word, or think another way. So we can delete the characters to make W2 equals W1. So in this case, so the dp0j will be the j. So this j can be interpreted as j insertions if we think to make W1 equal to W2, or we can think the other way. So make W2 equals W1. So this will correspond to j deletions. As I mentioned, insertion and deletion depends on which part to act to which part, right? So this is the first one. So in a symmetric fashion, so we can consider the first column, so from 1 to m plus 1. So in this case, so we are setting this one, right? So this will be I, right? So in other words, the word 2 corresponding to empty string, and the word 1 corresponding to a length I string. So in this case, we need either insertion j characters from to W2, or make I deletions from W1. So this is the this up to now we finished the deletions, and then the major work for I in range, so from 1 to m plus 1. So this I will start from index 1 and ending at m. So similarly for j in range 1 up to m plus 1. So this j will start from 1 and ending at n. So due to the range, we can interpret this I and j as lengths. So when we compare the characters, so we are going to use I minus 1 and W2, j minus 1, right? Because the index is one shift towards the length, right? So if these two are the same, so in other words, we don't need to do any operations. So this corresponds to dpij equals dp I minus 1 j minus 1, right? So otherwise, so we need to think of these three operations. So we want to first write this one and then explain to you what does it mean, right? So we need one operations, that's for sure, right? So if we consider this one, I minus 1 j, this means that we can think of this dp I minus 1 and j. This corresponds to delete the current character at the first word. And also if you think this I j minus 1, so this corresponds to delete the current character in W2. And another one, don't forget, so we can also do a replacement to make the current two characters equal. So this is corresponding to consider this, right? So basically you can think this is the 1 plus this number, and the 1 plus the second one, and the 1 plus this last one. So the first two corresponds to deletions, or you can think of another direction as insertions, and the last one corresponds to replacement, right? So with that done, we are ready to do the return. As we mentioned, we interpret ij as length. So here we want to return dpm, this is the length of the first word, and n, the length of the second word. So with that done, let's do a test. Here it's wrong. Let's see where is the problem. So we have mn, this length, right? So dp0 m plus 1 and range m plus 1. For j in this range, so we have dp0j. For I up to m plus 1, we have I0, right? So for I in this one, for j in this one, so then we have w1 I minus 1, w2 j minus 1. So we have dpij equals dp I minus 1 j minus 1. Then dpij equals 1. So here is not max. It's min, right? Because we want to find the minimum number of operations. So let's do a test now. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the cases. So that's basically about it for this specific problem. So here I want to make some comments. First, this question itself, though used by many companies like Amazon, Microsoft, Adobe, and TikTok. So this problem is a classic one, both from the coding point of view or from the fundamental knowledge point of view. For example, this edit distance is a very elementary or fundamental concept in information retrieval. So the way here we used to solve the problem is dynamic programming. So as for this current format of dynamic programming, it's important to align with your interpretation when we do the DP update, right? So once you make clear the interpretation and the DP recurrence or update rule, then so writing the code should be no problem. So with that said, I guess that's about it for this video. Thank you.